Hi everyone, today we are going to discuss about caching. So if you have ever wondered how applications serve the data so fast or why caching becomes tricky in distributed systems, then this video is for you. Let's get started. So what is caching basically? So caching is a process using which we store the most frequently data into the some in-memory location. Instead of going every time to database to fetch a data, we store that data in our in-memory and we fetch whenever a call comes to access that same data. We return that data from the in-memory instead of going to database. Let in this diagram also, if you can see, there is a server makes a call to the database to get the data. So usually DB call takes around more than 1 millisecond to, because it makes a network connection to the database, and then the query will execute in the database side, and it will take some time to return us the response. But with the help of caches, it can give us the data within nanoseconds, like because it doesn't need to go to the database, or it doesn't need to basically execute the query. It can directly go, and within go of one time it can directly get the data and it can return us. And it is simply in memory, so RAM access is 10,000 times better than the SSD. So that is also another reason why caches gets the data so fast compared to the database calls. Now the next point is where to cache, right? So let's say there are multiple places we can cache the data. One is external. External means basically there is an external server where we store all the cache related data. So whenever a client makes a request, the request comes to our app server, and then app server checks whether the data exists in the cache or not. If data is not exist in the cache, then only it will call to the database, otherwise it will return the data from the cache immediately. So this way the performance of our API will be improved. And next approach will be here in app server. Like whenever we have a monolith application and which has only single server, so in that case what we can do, we can use a cache within the app server, right, within the system. Like in case of Java, it will be in memory heap, where we can create a map, and map can store some data in the key value format. So that cache can be used here. So instead of whenever a client sends a request to app server, then app server directly fetches the data from the in-memory map and returns to the client instead of going to the database every time. So this will improve the performance more better. Next approach is CDN. So CDNs are basically content delivery network which are used to serve static content. Static contents, the content which doesn't change, like images, videos. They can be served by the nearest user location. Let's say some users are in Australia, some are in America, so the content for them can be served from their nearest edge servers. Like in AWS we have CloudFront, so using that we can serve the data. Next is client-side caching. We can do client-side caching also, like in the browser we can store data, like local storage there. So there we can store some tokens or some information which we think not harmful, and we can store in the client side also. So these are the places where we store the data whenever we maintain a cache also in our application. Next is, once we store the data into the cache, there are some strategies, you can say, to read and write the data into the cache. So basically first strategy is cache aside. So cache aside means first we will read the data from the cache. If data is not found in the cache, we will go to the database, and once we get the data from the database, we will update the cache and return to the user. So whenever next request comes, it will again checks the cache and it will found the data and it will return from there. So only first time cache miss will happen, but from the next time cache miss will not happen, and API responses will be fast. Next approach is write through. Write through is basically whenever we write the data into the database, before writing to database we write to update the cache, and then we update the DB. In this way some latency will be like higher side, but the cache and database will always be in sync. So that is the approach of write through. And then write behind is a strategy where we only write to the cache, and then cache asynchronously flushes to the data to the database. So this way we basically improve the latency, but there is a risk of if let's say cache server goes down, the complete data will be lost because we didn't persisted the data into the permanent storage. So that is also one approach. And then next is read through. In the read through, basically the cache talks to the database instead of user talking to database. Basically, when the cache talks to the database and updates the data into the cache, means cache connects with database and database sends the data back and it updates into the cache and user gets the data from the cache. This is read through strategy. So now after persisting the data into the caches, now the next thing is key, there should be eviction policies also, because we cannot persist all the data into the caches, right? There will be a limit of storage. So there is some eviction policies. First is LRU. LRU is the most common one, which is least recently used. So we need to evict items from the caches which have been used least frequently. Least recently. The items which are used least recently, we can remove. This is the LRU strategy. And then next is LFU. LFU is basically the item which are least frequently accessed. We remove that item first from the cache. Least frequently has a drawback. Let's say some item is accessed just now, but since it is accessed only one time, in the whenever new request come and if data is not present, like cache is getting full, we will remove that item. So that is least frequently used. And then next is first in first out, basically. So it removes the oldest item first. And then next approach is TTL. TTL is basically every cache, whenever we build a cache, we maintain a TTL. Like we can say in every 10 minutes we will flush all the data or remove all the data and reload data from the database. So this will basically remove all the data and updates the fresh data into the cache. This is the TTL strategy. After that, in distributed databases, we generally use Redis or Memcached for the caching purposes, because Redis multiple servers can connect to the Redis cluster and they can get the updated data from the cache. I think that's all for this video. Thank you. Let me know if there is any doubts.